stage Ryan Lewis and Adam Van Etten of Spacenet.
I want to wrap up with. Okay, sure.
All right. Good morning, Topcoder community. It's great to be here.
Okay.
We're particularly excited to be here because this is the first time that we've ever attended a Topcoder Open. And it's particularly interesting because we have been working with Topcoder over the last 3 years. And so as you got from the introduction, so why are we here? We're here because our group across all the different Spacenet partners fundamentally believe that machine learning is going to change the way mapping and more broadly geospatial applications are executed in both government markets as well as in commercial markets. And yet one of the big problems that we see is that so much of the advancements that are occurring in the computer vision community are not designed for satellite data or any type of overhead data. Looking for or detecting cats, albeit that is a huge problem, is very different than detecting things in an overhead image, specifically for something like mapping. And so how do we, as a group, help solve this problem? Well, we came up with the idea that we need to help build a community, or in this case, leverage one. And so we started Spacenet LLC. It's a nonprofit group that's run in collaboration with 6 organizations. So my group, it's In-Q-Tel Cosmic Works, along with Maxar Technologies, Intel AI, Amazon Web Services, Capella Space, and Topcoder. And one of the big things that we have focused on for the last 3 years is iteratively building not only interest in this sector, but also building out capabilities. And so what that means is that over the course of each year, we will launch different data science challenges on Topcoder along with open data sets. And then after those challenges, we will open source code along with detailed evaluation of that code. And what's been really exciting about this is that when we first started, we had no idea if anyone was going to use it. And it was slow going at first. Fast forward to today, we've had roughly, we're a little under 500 million unique hits across over 10,000 unique IPs in 82 countries. And so for us, we could not have done that without the breadth and reach of the Topcoder community. And one of the big things that I think has been a secret to our collective success and the engagement with the community has been taking a very iterative approach to the analytic challenges that we ask competitors. And I'll have my colleague, Todd Backistow, walk you through what we've done over the last 3 years. And then Adam will talk through the most recent challenge, Spacenet 5, which we just closed 2 weeks ago. So Todd?
Great. Thanks so much, Ryan. It's really a pleasure to be here. It's a very exciting event, and it's great to see the community come together. So I'm Todd Backistow with Maxar Technologies, and as Ryan said, we started Spacenet about 3 years ago. We saw an incredible need to apply computer vision technologies to geospatial data, specifically satellite imagery, to help automate what had traditionally been very manual tasks. So to give you a sense of the amount of imagery, so Maxar collects over 3 million square kilometers of satellite imagery a day, and these of course, produce beautiful images, images that we can see change in important events around the world. But there's a lot of information that exists in these pixels. And so traditional methods, whether it's foundational mapping or to identify features in the imagery, have largely relied on manual means. So these are imagery analysts or other users who access the data. And this may also be done through online mapping platforms where they pull up the imagery and they start to extract points, lines, and polygons, what we call vectors. These often represent infrastructure or other features on the map. And we saw, as we looked at some of the trends in the broader computer vision space with projects like ImageNet, we said, well, we have a 100 petabyte imagery archive that goes back to 1999. There's an opportunity here to apply some of this technology to extract information from this at scale. So we started, we just completed the 5th challenge, and we started literally looking at building footprints and trying to identify these features that could be extracted. So we labeled training data sets and released them as part of Spacenet along with the imagery, and then continued on through roads, and also looked at some of the nuances of satellite imagery. So we often, for mapping purposes, will collect the imagery looking straight down, but as our emerging constellations come online, they'll start collecting imagery at what we call high-off nadir angles. So these are angles other than straight down, and they can actually affect the performance of the algorithm. So through the course of the 5 challenges, we've been able to help advance the technology working with the Topcoder community. It's been a really great project to be a part of. So, and we're, I think there's a ton of great things we can do as we continue to develop this technology and capability working with the Topcoder community in the future. Adam, do you want to talk about some of the specific challenges?
Yeah, thanks, Todd. I'm Adam Van Etten, also with Cosmic. And so Spacenet 5 just closed, as was mentioned already. And for this one, we really decided to push the envelope. So we've looked at building footprints before, but another thing you might care about with foundational mapping is roads. And so people have done this before, but usually it's looking at a pixel mask, right? Which pixels road, which pixels background. What's more interesting is the actual graph theory, the graph structure, right? Can you actually give me the network that you can route on? So for Spacenet 5, what we said, let's give me the actual network you can route on, starting with nothing but satellite imagery, and also the travel time, the speed and the travel time for that network. And you can imagine this applies to a lot of different problems, right? If you don't have a good map because of a disaster or something like that, if you can directly pull out a routable road network with travel time estimates, this is something that's very useful potentially on the ground if you don't have a good thing to start with. That was the challenge, right? And so we posed this to competitors. We also added 4 new cities to the Spacenet data corpus, which expands our coverage out to 10 total, right? We added thousands of kilometers of labeled roads. These are labels from hand-labeled experts, expert labelers. And so we're pretty excited about that. Ran this challenge, and there's one more tweak, right? We really turn up the wick here, which was we held back a city that no one knew about for final testing. So you have a couple cities to train on. We test on one city publicly, which is San Juan, Puerto Rico. But then the holdout city, no one knows about until right now, was a city on the east coast of Africa, about 4 million people, which was Dar es Salaam. And so that formed the majority of the final testing score. So you can really see people build these algorithms. Do they actually apply to an unknown geographic area, right? Can you actually apply these in a real world? And that's what we're seeing. And we're actually seeing pretty good scores. We can't get into the final score yet. It's been a challenge, so we're going to release final scores in the next few days. But it's been a big success. We're really excited to release some of those outcomes and show how you could actually use this on a large scale for a disaster response scenario.
I think looking ahead, if you're interested in any of the results, technical analyses, downloading the data set or code, you can find all that information on spacenet.ai. And it's important to note that this is something that, as we said, we want to continue to build upon. And so as a teaser, we're looking to launch Spacenet 6 on Topcoder in February, and this will be our first effort into multimodal data analysis. So not just looking at high-resolution satellite imagery, but also combining that with synthetic aperture radar. And so we'll be posting more information about this in the coming months, and we're really excited about it. But we really couldn't do all this, and we couldn't have the results and feedback that we've had without a lot of help from people in the room. First, a big thank you to all of the Topcoder competitors. We've gotten to know a lot of you over the years. My favorites are the ones that send me late-night Twitter messages or just like everything we put out, so thank you to that. And then also a special thank you to a co-pilot of ours throughout the years. He's kind of become a mythical figure, and it's great to finally meet him. So Balaz or Walrus 71, if you could just stand up. I feel like we owe him a huge gift because we're always sending him late-night notes, and he's been great to work with. Also, just to close it out, just a big thank you to a lot of the folks here at Topcoder, from Andy, Michael, Clinton, Ryan, Alexis. It's been great to work with all of you, and we're excited to launch Spacenet 6 and to continue this relationship. So thanks for all of you. We're happy to take questions afterwards and looking forward to everything that's next. Take care.